Alright guys, we're looking at the trig ratios in practice with numbers this time. So we have a triangle here. It's triangle ABC. Like I mentioned in the last video, most of these are going to be labeled are going to be triangles ABC. Instead of having the lowercase letters for the different sides, we actually have numbers now instead. So back up here, we have the small letter where little a was opposite of a big A, little b was opposite of big B, and then little c was opposite of big C. And we were working with these trig ratios of sine, cosine, and tangent. So thinking back to that, and if you didn't write down those on a different you should have a note sheet that you're filling those out on. I'd make sure that those are filled out. But here are we have two practice pieces for our trig ratios. So we're dealing with numbers. So instead of having like we had up here where it was a over c, where it was side opposite of a over hypotenuse, now we're going to be dealing with numbers. So note that I have one set that says sine of a, cosine of a, and tan of a, and I have one that's sine of b, cosine of b, and tan of b. And that's because the answers change depending on what angle we're looking at in our triangle. So our first set here, these are going to be looking at angle A. The second set are going to be looking at angle B. So I'm actually going to highlight some of these with colors. We're going to make our hypotenuse red, so I'm going to box that in red. So when I write it down there, you'll see it the same color. We'll make our side between A and C, it's opposite of side B. So really you could think of this as being a little b. And then our side little a is going to be 5, and we're going to have that in green. So this would be little, sorry, not little a, this would be little c there. So you have the letters there, you know what we're referring to. So for sine of A, if you go back to your notes on the previous section, is opposite of A, or just the opposite of the angle, over the hypotenuse. So if we're looking at A here, opposite of A, or little a in this case, is going to be 5. So in our numerator, this is going to be 5. Now, this is over hypotenuse, which hypotenuse is represented by the little c. It's always the side that's right across from our right angle, which in this case is, in most cases for the problems you'll see, is c. So this is going to be 5 over 13. And then this would be our trig ratio. That would be our answer if you were just asked to find the trig ratio, which the first part of today's assignment, you are just asked to identify the trig ratio. Now if we look at cosine of A, I'm going to go and put the fraction pieces in for all of these. If we look at the cosine of A, we now change from, instead of being the opposite side of A, we're looking at the adjacent side. So we're looking at the side that's next to it. But keep in mind it's the side next to it that's not the hypotenuse, because technically the hypotenuse is right next to A, but we want to look at the side that's right next to A that is not the hypotenuse. It's one of those legs. So in this case, we're looking at side B, which in this case is 12. In the denominator, we again have our hypotenuse, which is going to be C. So in this case, it'll be 13. So I didn't do this before. I'm going to actually label it. Technically, this is A over C. This one would be B over C. And then our last one we have here is our tangent. And this is the one that doesn't use the hypotenuse at all. It's going to use our opposite of 5 over our adjacent of 12. So this ends up being A over B. So this is the letter correlation with what we had above here on the last piece. And these numbers are then pulled from this new triangle here. So we've just taken in, so for all of our A situations, we had 5 go in. For all of our B situations, we had 12. And then all of our C situations, we had 13. Now, here's where this can get a little confusing. And that's when we switch the angle that we're looking at. So now we're going to look at the other angle that is not a 90-degree angle, and that's B. So I'm going to kind of label these out the same way I did before, except for I'm actually going to flip them because it's usually better to put the letters first. So for sine of B, when we're looking at it, our opposite angle actually changes. Because originally for A, our opposite angle was A. But now with B, side A is actually right next to it. So that means our opposite side now is going to be little b, which is 12. So sine will be opposite, and it's still over hypotenuse, so that this doesn't actually change. It stays b over c. So the c stays the same, but our opposite now has changed to being little b, which is now 12. So we're still working with sine, but since we've changed our angle, we've changed the perspective. Because for A, 5 was the side that was opposite. For B, though, 12 is now the side that is opposite. So that's what changes on there. Now, oh shoot, I actually wrote down C again. So this should actually be 13 here. For cosine of B, our hypotenuse again stays the same. So it's still going to be 13 in the denominator. But in the numerator, it's our adjacent. And our adjacent now in this situation is A. That's the side that's right next to angle B. So this is now going to be A instead. So note that what's happened here is these things have just switched places. Our sine of A is our cosine of B. Our cosine of A is our sine of B. So they actually flip spots. Now when you look at the tangent of B, it's really just an exact flip. Instead, since we're looking at B, it's opposite over opposite over adjacent. So our opposite is now going to be B over our adjacent of A, which our B is 12 and our A is 5. So that's actually the exact flip from the tangent of A. It's just flipped what's in each spot. So for sine of A and cosine of A, they've actually flipped to being sine of A being cosine of B and cosine of A being sine of B. Tangent of B, the ratio itself has flipped instead. Because the hypotenuse stays the same, but which one's the adjacent and which one's the opposite changes depending on which of these two angles you're looking at. You'll never see something that's like tangent of C, because C is our right angle, and we ignore the right angle. For all of this to work, that right angle has to be there, but all of these trig ratios and these trig functions work off of the two side angles rather than the right angle itself. If you have any questions, get with me in class.